Good afternoon, everyone. I'm Professor Flavia Lopes from Federal University of Rio Grande do Norte, Natal, Brazil. First of all, I want to thank all staff members for organizing this meeting, this incredible opportunity to share knowledge during such a typical year. And today, I will present part of the dissertation of my graduate student, Elionaide Martins, the second author here. Our research developed with the core supervision of Professor Felipe Nalon, the other author that we have here. So, let's talk about the evaluation of food neophobia in twins. Maybe it's quite obvious, but it never hurts to remember that a balanced diet is essential for the proper functioning of any organism, including us human beings. At the same time, to decide what to eat may not be an easy task. Each decision involves external influences and also internal states and motivations. In this sense, we cannot forget individual differences that can influence the decisions. For example, some people present an individual resistance to experiment new foods. Sometimes the resistance is so intense that it can result in a complete avoidance of new items. In literature, this reaction is described as food neophobia, as we are pointing here, and it has a clear evolutionary function, this reaction. As omnivorous species, we developed this defense mechanism to avoid poisoning, for example. So it's really important a reaction has food, the reaction in the presence of new food or food neophobia. But the manifestation of this reaction can change during development and can be different between individuals. In this representation here, we have the expression of food neophobia in different moments of our development. So the levels of food neophobia here and our stages here. As we can see here, at the beginning of our lives, the levels of food neophobia are really low. And as we can see here, between 2 and 4 years old, we have extreme food neophobia reactions. That tends to decrease when we get older. Some people, depending on experiences through life, can maintain higher levels of food neophobia. Okay, so how can we explain the individual differences in these reactions? Why some people reacted in a more intense form and why other people are not so neophobic? Of course, we need to talk about genes. These structures allow organisms to respond and use what is around them in the environment. And how it happens? Through heredity, structuring our potentialities from our ancestors, or through heritability, explaining the phenotypic variation in a population due to genetic variation. Okay? Twins could offer an incredible opportunity to test some scientific hypotheses. Their condition works as a natural control of essential variables such as genetic similarity and shared environment. In previous research, it was observed 69% of heritability in the expression of food neophobia in adult twins. So, our main objective was to evaluate food neophobia and its associations with zygosity in adult siblings. Our hypothesis was that the expression of a neophobic behavior differs between pairs of monozygotic, dizygotic, and non-twin siblings. We had the expectation that the differences in this expression of this behavior will gradually increase as the genetic similarity decreases. We had 138 participants with an average age of 26, with a majority of female participants as usual. We compared 3 groups of siblings, monozygotics, we had 35 pairs, dizygotics, only 8 pairs, and non-twins, 26 pairs. We used heads pointed here. We use a Brazilian version of food neophobia scale, FNS, which addresses attitudes related to acceptance and consumption of unknown foods. We also used the zygosity questionnaire, self-report measure used to classify twin individuals, and also we calculated the heritability of food neophobia trait using a formula proposed by Gelman et al. That unfortunately I can't explain in detail, but I will show something for you. So the food neophobia scale has a score from 10 to 7 points, and we use it here in this work the classification of Flavia et al. That suggests scores lower than 30 points. We consider this individual as neophilic, between 31 and 49 points neutral, and scores above equal or above 50 points, we can consider the individual as neophobic. When we consider the zygosity questionnaire, the score ranges from 6 to 20 points, and scores between 6 and 13 we had monozygosity, and scores between 14 and 20 we have dizygosity. The heritability calculation, we use this formula as we talked about earlier, and here we have all the variables considered for this calculation. And it's important to notice that when this equation was near or equal to 0, the variation is attributed entirely to environmental effects. So here we are measuring the variation that can be related to genetic factors, okay, when we use this calculation. To analyze data, we create a variable called a difference in neophobia. This variable has allowed us to compare the similarity or difference between siblings in the food neophobia response. We subtract the FNS scores of each pair of siblings, sibling A and sibling B, in each group of siblings, so monozygotic, dizygotic, and non-twins. Then we compare the differences for each group using a Kruskal-Wallis test. And also we calculated the heritability index, and let me show you what we found. Well, as we can see in table 1, using a Labi et al. Classification, according to FNS, food neophobia scale, it was observed that among monozygotic and non-twin groups, most participants were classified as neutral, with the dizygotic group having a higher incidence in the neophilics category. Considering neophobic participants, similar percentages were observed between monozygotic and non-twin groups, being lower in the dizygotic group. When comparing the classification of each individual within each pair of siblings, we observe greater similarity in the categorization between monozygotic twins, as we can see here in blue, and less similarity in the classification between non-twin siblings, as we can observe here in red. Okay. The group of dizygotic twins showed an intermediate result. The difference in the scores of the final food neophobia scale score was performed between siblings A and B, okay, as we explained before, and transformed into positive values through the z-score in absolute measures, as we can see here in the figure 2. Although we did not observe a significant difference between the groups, here we have the statistic result, the tendency of monozygotic twins to show less difference with regard to neophobia is noteworthy, with an increase for the zygotic twins and with the biggest difference between non-twins siblings. So something like this. We observe this increase. Finally, the calculation of heritability index obtained through variance in the final food neophobia scale score between twin siblings was carried out and resulted in a percentage of 29, being classified according to Oliveira as moderately low heritability. We can point out two aspects. First, the observed trend seems to follow the expectations of the study, in which the monozygotic twins have less difference between them in the expression of neophobia, followed by the dizygotic twins increasing a little more among the non-twins, as we see in figure 2. Heritability index showed heritability of 29%, mild for the neophobic trait, but this could be good news in some sense. Let me explain this. The environment could be responsible in a great portion for the expression of this trait, which can be a good indicator from a clinical point of view of a context in which strategies are thought to make it possible to reduce the effects of food neophobia. So we can think of a better diet quality with an opening to include new items, and also we can think or we can use the social factor as a good modulator for the food neophobia. So that's it. Thank you so much for being there. Again, thank you very much.